Hi everybody. Welcome to London's Calling. Thanks for coming to my talk on test-driven development and why you should be using it. And you should all be using it if you're not already, and hopefully by the end of this talk you will all be using it. Just a little bit about myself. So my name's Chris Aldridge. I work as an independent consultant under the company name Silver Softworks. My background is Salesforce. I've been in Salesforce for about 3 years now. Spent 2 years working for a platinum partner. I've been contracting for around about a year, and I decided to go out on my own about November last year. And before that, I was a .NET developer for about 8 years, working in the travel industry. My blog is available here if anyone wants to go and look at that. I'm still fairly new to blogging, so go easy. Don't abuse me too much in the comments. Yeah, I also just want to take this opportunity just to say I've never stood up in front of people like this and done a talk. I'm a bit nervous, go a bit easy on me. So, test-driven development. So this is a quick overview of the talk today. So we're just going to talk about what it is, how we apply it. We're going to look at some code. You're all code hungry, so we'll be doing that. We're going over some of the advantages of test-driven development. I've chosen not to use the term disadvantages, but to use the term barriers. This is a very one-sided talk. And I'll be giving you all some tips for how you can go out and get started, and then we'll do some questions towards the end. So, who here knows what test-driven development is? Yeah, quite a few of you. Who's a developer and doesn't know anything about test-driven development and you're brand new to it? Nobody, excellent. I'll expect some really difficult questions later then. Who here uses test-driven development at the moment with Apex? Nobody. None of you, and that's exactly what I thought the answer would be. It's really strange. Like, I come from a .NET background, as I mentioned, and in .NET, you can't get a job anywhere if you don't know test-driven development. I would say 90% of job postings. So who here wants to tell me then, seeing as you're all experts already, who wants to define what test-driven development is for me? Any volunteers? Quick one, come on, someone put your hand up.
So you essentially write your tests before you write your Apex code.
Writing your tests before you write your Apex code. Almost word for word. So a software development approach in which unit tests are written before the functional code. Yeah? So that's bang on. And if you go and Google test-driven development, that's exactly what you're going to find. I don't think that's a very good definition personally. I prefer this one. The technique of using automated unit tests to drive the design of software and force decoupling of dependencies. So essentially, I guess the reason I prefer this one is because it straight away points out it's not just about flipping around, doing unit tests first, and writing your code second, which is what a lot of people think it is. It's really about really kind of changing your entire approach to writing code. I know it sounds really dramatic, and there's probably some naysayers in the crowd, but genuinely, it's really about flipping the whole design process on its head. Forcing decoupling of dependencies, again, especially in Apex code, we tend to have things like triggers, we use controllers, we use sort of utilities classes and stuff like that. And a lot of the code that I've written and I've worked on from other people and I've seen at other companies, there's a lot of dependencies in that code. Other areas in the industry, people tend not to do that, try and decouple their code. They use dependency injection. In Apex, that doesn't tend to happen, and because of this, you kind of unit tests, they kind of bleed into each other. Speaking of unit tests, I'm not going to bore you about unit tests, but we're just going to quickly recap what they are. So a unit test, an automated test in which the smallest testable parts of an application are individually and independently scrutinized for proper operation. So the reason I'm going to give you a quick lecture on unit testing is because if you don't sort of follow very strong unit testing best practices and good OOP practices, you're going to find it really difficult to pick up test-driven development. So again, unit test best practices, so you can find these on the Salesforce website or really any website to do with unit tests. We all know this. I don't mean to sort of teach you to suck eggs, we all know this, but let's quickly recap. Unit tests should be isolated and independent, so we're not bleeding on each other, not sharing data. One behavior per test. So this is, for test-driven development especially, it's really important that you don't have these kind of all-seeing oracles that are testing loads of your code, and when one piece of code goes wrong, all your unit tests blow up because they're bleeding into each other. Arrange, act, assert is a way of structuring a unit test, so there's 3 stages to them. The arrange bit is where you set up your test data, create your custom settings, insert your test records. The act, you're doing one thing, calling one method, usually. And then your assert piece is, did that test do what I thought it was supposed to do? Deterministic, if you run your tests, at 11 o'clock on a Friday and then 11 o'clock on a Sunday, they should do the same thing. Any 2 times we run them, they should be doing the same thing, not relying on external stuff. Removing dependencies, again, it's one of those things that I'm going to talk about quite a lot today. If you're really looking to start with test-driven development, or if maybe you've tried it and have not got on with it, this is probably the culprit. If you've got dependencies among your code, you're going to find it really difficult. And they should be readable. If I'm looking at someone else's code, it doesn't work. Usually the first place I look is the unit test, because they should describe what should happen when that code is run. Right, so enough about unit testing, because it's boring. But back to test-driven development, which is exciting, obviously. So, test-driven development, again, if you Google it, you'll find a kind of 7-step process. So, the general idea, as our friend over there just said, is that you write your tests. So let's say we've got a system with 5 requirements, for example. This is going to be a really basic example, right? So you've got a system with five requirements. First thing you're going to do is you're going to go in there, take your first requirement, and you've got to write a unit test that says, when I do this, this should happen. You're going to run your tests. The test's going to fail because you haven't written the code yet. So that's our red part of our diagram over there. Next thing we're going to do is we're going to write some code to make that test pass. And when I was demoing this to Simon Goodyear, who was not in here, Simon, one of the organisers, he kind of questioned me about this bit, because I think this is really where he kind of went wrong. You should only write the minimum amount of code to make your test pass. Don't start thinking about what your next requirement is. Don't start thinking about the wider system. Simply write some code to make your test pass. Run your test, you get a green light. At that point, you're going to look at your code and say, can I make this code better? Can I refactor this code? And that's really important. We'll come back to that just in a second. And then essentially you start the cycle again. So you've got green light, you go back, you write your next test, you run it, you've got a red light on your new test, but a green light on your existing one. And you just do this process. In our test, in our sample, which is talking about, there's five requirements. So you're probably going to write 5 tests, and you're going to end up at the end with 5 green lights. So I talked a minute ago about my definition of test-driven development. It's not mine. I've found it online. The one I've stolen. It kind of talks about changing the development process and driving the application design. And a lot of that is because you're only attacking one requirement at a time, which we're all developers here. What do we do when we get a problem? We try and think, firstly, how can I address all of these in one piece of code? Sometimes, in one method, which might be 1,000 lines long. And not only that, we tend to start thinking about future requirements. What if the client wants to do this later? What if they want to do that? And that's one of the things with test-driven development that you'll probably find jarring if you get started with it, but it's really important, is that it makes you simply focus on one task at a time. I think that's it for that slide. But if you want to go away and you want to start this is the bit you've got to remember. Don't worry about the 7 steps. Red, green, refactor. That's the system. You need to say that over in your head. That's your mantra. I say that quite a few times in a day. I think the other thing as well about this process, again, getting back to not just flipping your unit tests in your code, but actually changing how you design a piece of code, is that, who here has ever just written a load of code and assumed it's going to work, and then later on found out there's a bug in it? Yeah? Anyone ever done that? Oh, all of you put your hand up for that. Yeah, if you didn't put your hand up, then you're lying.
I assume mine's not going to work.
Well, funnily enough, that is the difference here. So there's a really good phrase in test-driven development that I like. It's all code is guilty until proven innocent. So what we do is, we know right from the start, our code is going to fail from the outset, and it's up to us to prove that each requirement can pass. That's actually the opposite of what we normally do. And a lot of us are probably experienced developers. I've been writing code for 10 years, and I can be pretty arrogant about it. And I will just sit there and write a load of code and go, yeah, that probably works. And then later on find it's absolutely busted. Or more importantly, or maybe my customer finds that out, which is a little bit worse. So that's kind of a quick overview. Obviously, we want to see how it works. So what I've prepared is a very, very straightforward exercise for us to just quickly flip through. And it's all about calculating leap years. Yeah, you've probably seen this kind of exercise a lot. I did think about doing a bowling scoring game or a fizz buzz game or something like that. But what I want to do is put a problem in front of you that we all are familiar with and we probably all know the rules about. And we're going to build a piece of code that basically tests this. A very impressive piece of code, I'm sure you'll agree when we get to it. So basically, the reason I like this is because there are 5 rules. Yeah, so we just talked about a 5-rule system. There are 5 rules for leap years. If the year is before 1582, can't be a leap year because leap years had not been invented yet, which I didn't actually know until I researched this. If the year is divisible by 4, but it's not divisible by 100, then it is a leap year. So if it's 1996, if it's 2004, it is a leap year. If it is divisible by 100, then there's two different scenarios. If it's divisible by 100, but it's not divisible by 400, then it isn't a leap year. Okay, I can see you're getting very excited about these rules. I know these are really new, exciting stuff, groundbreaking stuff. If the year is divisible by 100 and 400, then it is a leap year, the year 2000, 2400. And basically, if none of these rules are met, then it isn't a leap year. Okay, everyone understood that? So let's look at our code. As soon as I can figure out how to get onto that screen. There we go. So I'm using the Cloud9 Idea here. I don't know if anyone uses that. Yeah, one person, excellent. Do you work for Cloud9? The reason I've used this is because actually the unit testing side of it is really good, although it has actually forgotten all of the icons that I was going to be relying on for this demo, so I have to get those back. So we're going to tackle our problem we were just talking about. So what do we start with? So we start with... I don't know. Can anyone else not see the code? Okay. It's all right. I'm just, because I'm in the idea, if I blow it up, I don't know if it's going to make it go crazy. So we're going to write this service. So talked a little bit about kind of structuring your code. So we're going to build a Visual Force page that tests this. Notice I've not written the code straight in the Visual Force page. I'm writing it in its own little service, encapsulating that code. Really straightforward method. Is leap year? It's going to take in a year. It's going to return a Boolean true or false, whether it's a leap year or not. You probably noticed that straight away I've written return null in there. It doesn't do anything yet. The first thing I want to do is write my first test. So here it is. So I've named the test. Is leap year returns false if year before 1582? Quite a long name, and I know people like to do things like is leap year underscore test, is leap year underscore test 1. I like to name my test methods with what's going on, so that when that test fails, we know exactly why it's failing. By the way, I forgot to mention, so this code is on GitHub. It's in the slides on GitHub/Chris Aldridge, London's Calling. Also, what I've done is, because we're going through like an iterative exercise, I've versioned the code. So normally you'd obviously only have one class and one test class. I've just versioned it so that if you look at the code, you can see kind of how we got to where we got to at the end. So don't worry, in test-driven development, you don't have to write 12 classes for a 5-line piece of code. So in the arrange, we're basically going to set up our year, which is going to be 1580. We're going to set up our service, and we're going to do a test to see if it's a leap year. And we're asserting, because it's 1580, that that should not be a leap year. Okay, it's not rocket science. If we just go off and run that test quickly. Oh, there you go, it's already run it. So that test has failed, so that's our red. I know this is a really basic example, but imagine this is something that's slightly more complex. So it's just come back and said, look, you've told me you're expecting a false, actually that's returned me a null. So that's fine, so that's our first step. Then what we want to do is we want to go ahead and actually write a piece of code that satisfies that test. Let's get out of there. Don't worry, I'm not going to go through too many iterations of this because I know it's hard to stay awake. So let's just go back in here. So what I've got in there is return false. Okay? Does that look wrong to anybody that I've done that? No one wants to put their hand up. So typically, the way I would normally approach this is I would probably put in like an if statement and said, look, if it's before 1582, then return false. But remember, we're going to write the minimum amount of code to pass our test. The first test always looks a bit strange because it doesn't really do anything. But as we go on in a couple more stages, you'll see that it starts to grow a little bit. So if we look at version 2 of our test class now, so it's the same test, as you can see by the tiny little green square there, that's passed. Okay? Everyone following so far? Yeah? If you do at any point in this talk want to just run out and start using TDD immediately, I'm absolutely fine with that. I support that. So now we're on to our second iteration. As I said, I'm not going to go through 5 iterations, but our second iteration is going to be, let's take our second requirement, which is, if it's divisible by 4, but not by 100, then it is a leap year. So again, I mean, these unit tests, I've basically copied and pasted them. In reality, when you get started, you probably all know from writing unit tests, I would actually refactor this all out, and I would have a setup method probably, because the setup's all pretty much the same. But just to make it nice and concise, I've left it like this. So setting up my year 2004, calling the method, and I'm going to assert that 2004 is true. And as expected, we've got an orange light there. The test has failed. I ran all these tests earlier to make sure they're all nicely prepped. So that's failed, and again, you can probably guess what's going on there. So, something else to mention is that I've deliberately written some bad code here, right? So as we go through this, especially when we get to the last version, you're going to notice some really messy code. That's deliberate. I'm not just saying that. You'll see why a little bit later. But as you can see, I've basically put in like a nested for loop. So I've gone in there, and the code's grown a little bit now because I need to meet not one requirement, but two. After this point, we'll only ever have to meet one extra requirement. So that's the code. It's not great. But the test passes, and that's the important thing. And the next stage is, so it goes red, goes green once we've written the code. So we go and look at version 2 of the test class, which goes with this piece of code here. We can see that it's got a green light. So we know that those two requirements are now met. Our system's kind of moving towards where it should be. At this stage, what I didn't do the first time around, because there was one line of code, I would look at this code and say, right, now, can I refactor this? Can I make this better? Absolutely, I could. I'm not going to do it just yet. I'm going to wait till we get a little bit more complex. But it's really important that we do that, because otherwise we're going to end up at the end with probably 5 if statements is how this is going to evolve. And that's exactly how I've pretty much done it. But that refactoring stage is the most important part of this, really, because it means that as you go along, your code's going to get better. You've got to clean it up every 10 minutes, every 15 minutes. Every time your tests pass, you're going to revisit that code and say, what is wrong with this? Can I make this better? Is that testable? Do I have dependencies in there? Which typically, again, going back to the kind of old way of doing code, how many people here have ever written a method and looked at it at the end and gone, well, that's too long, but I haven't got time to go back and revisit all that now. Yeah, we've all done it, yeah? You can't do that with test-driven development. It is impossible as long as you follow that mantra.
Isn't that always going to return false? It's supposed to always return false.
No. So if it's the year is after 1582 and it's divisible.
It comes out of that.
Yeah. And I know that's the case because my unit tests are passing. I did not plant him in the crowd. So let's just whiz right through to like version 5 here. So our last test, let's look at version 5. Yeah, so again, I'm not going to bore you with all of these, but essentially we go through that process, we add a requirement, we add a test, we run the tests, we write the code, we update the code. I haven't done the refactoring deliberately, but I mean, as you can see, this is probably not the best way of structuring this fairly straightforward bit of code. We've got some nested if statements in there, we've got if then else's, and personally I don't like writing code like that. You may do. So I've then gone out and refactored this. You may not agree with how I've written it there, but I think I've tidied that up a little bit. I like short returning code. But the important thing to note here is that basically between version 5.1 and version 5.2, I've completely restructured that code. And this is kind of one of the most important things about test-driven development is that I've restructured that code, and as soon as I've run these tests, I know that despite the fact I've changed it, or despite the fact I've refactored it, I may have moved classes around, changed things into private methods, done whatever it is I've done. All I've got to do is push a button, and I know straight away that all my code is still working, all my requirements are still met, and if I've broken anything, I'll know straight away. And especially in a more complex system than our little leap year piece of software here, it's really good to know straight away when things are failing. When you find 3 weeks down the line that something's broken, it's really hard to find out where that went wrong. One other thing I just want to point out as well, so we've done like one test per requirement. Another really important reason for putting unit tests in is when people report bugs, or if you find a bug in your code, or if you have a concern. So, a user comes in and they say, I'm passing in, I don't know, the year 2850 and we're going to stop using leap years in 2840, for example. First thing I would do is I'd come in and write a unit test, run it. Yeah, my system doesn't handle that. Fix the code up, and then I know that bug can never be reintroduced. And when you're on a big system and you're changing other people's code, that's really good. And it's a massive time saver to know that you push a button and you know straight away that everything's working as it should be. That doesn't mean you'll never get a bug. I'm not going to go that far, but it really does reduce the amount of bugs you come across. One other thing I just want to talk about briefly as well. So we talked about basically hosting this on a Visualforce page. So this is a really basic example. None of us actually write code like this. None of us have probably got any classes that are 5 lines of code long. The other thing is that this code is not currently talking to any other code. And this is kind of, with test-driven development, I think this is where people start to lose patience, because now what we want to do is we want to plug this into a controller and a Visual Force page. And we've got to unit test our controller because we're doing test-driven development. We're going to test everything. So who can tell me for my controller, which I'll show you in a minute, if we're going with test-driven development, what would be the first unit test, test-driven development or not? What would be the first test you run on that controller? Anyone want to volunteer? It's not a trick.
Return none. Is that what you mean, or just?
So what I mean is, sorry, maybe I've not phrased that very well. What are the requirements? So on the controller, I'm going to have a method. So we're going to push a button, and it's going to check the leap year. So what would the first test be, do you think? What's the first requirement for a controller in that respect? Imagine your unit testing that method. What's your first line of code going to say? What do you think? You don't want to answer? Okay, or I'm not answering the question. So typically, the way I've seen this approach is that people will go in there and they'll actually test that when they feed 2000 into that controller and push the button, that they get a true back. Yeah, is that what people do typically, or you've seen that? So there's a problem there, and the problem is that we're actually testing the service and we're not testing the controller. The controller, really, if we go and look at this, and if you've not seen sort of dependency injection and stuff like that, just ignore this for a second. And we're just going to really skip over this because I've not got time to go into detail on this. But so this is my check leap year method. And it's basically got 2 jobs as far as I'm concerned. One is that it needs to check and see if the input number is a leap year, and it needs to store that in a property on the controller so that can be shown on the page. So that's my first unit test. The other thing is that when we call that service, it could throw an exception. And with a Visual Force page being a user-facing piece of functionality, I want to make sure that if an exception does get thrown, it gets added to the page. Who here has ever had problems unit testing what happens when an exception gets thrown in Apex? Yeah, see some nods, people reluctant to put their hands up. There we go. It's a really big problem. And typically what happens, I was working for a customer a little while ago where there was some batch processing that was crunching a load of numbers. Another developer had written the code, and he put some logic in here that basically went off and logged the error. So there was a batch process running. It was for a financial institution. It was pretty important code. But he'd written this catch block, and it was supposed to log the errors. It just wasn't working. It just like there was an exception being thrown. And the problem was, it was not even his code that was wrong. It was something he was calling that had bubbled up. He'd caught it. And he had no way of testing. He said to me, like, how do you test exceptions? Like, you can't do it. So the answer to that, and probably all of your ways when it comes to test-driven development, is going to be something called dependency injection. What that basically means is that we're going to split out our controller, and we're going to split out our service. We know our service is working, right? We've already tested it, so we know that that's working 100%. If you look at the code on GitHub and find a bug, please just let me know quietly. Don't post it in the comments or anything like that. So we need to make sure we can test this controller basically without relying on that underlying service. If someone comes in and breaks the service, the controller test will break and we won't know where the bug is. In a more complex system, you might have triggers, batch processes, they're calling services, they might be calling out to web services. What we're trying to avoid here is like something goes wrong downstream and then all my tests start failing because I'm relying on someone else's code. So what we do is, like I say, so there is a talk, there are a couple of talks this afternoon that are going to go into this in a lot more detail, but essentially what we're going to do is separate those 2 things out. And I've been told I'm not allowed to go into too much detail on this. But, so my controller is going to have 2 tests basically. One that says, it's basically what's happening is I'm creating a test double for the service. So instead of actually relying on that test, we put in like a pretend version of it and we know what the answer is going to be every time. So even if someone breaks that actual service, we're not touching it, we're using our own version of that code, which literally just, we program it, we tell it what to return. We say, look, when I call you, just return true. Yeah, some of you may have seen mocking before. Mocking is basically kind of an extension of this. But this is the kind of biggest challenge, I think, with test-driven development, is when people start getting into this domain, it gets very confusing. I can see a few people looking confused already. We'll come back to that. But the point I'm trying to make is that if you're going to use test-driven development, this is one of the things you need to be able to do. You need to be able to split out your code, test each bit in isolation, make sure the things are doing their own job. We're not relying on the controller to go off and calculate these leap years, for example. We're not relying on a trigger to work out if an opportunity should be in a particular stage. We just want to make sure the trigger actually calls the right thing and does the right action. Okay, quickly jump back to my slides. Okay. So that was a really quick demo of TDD. I don't expect it to have blown all your minds. Yeah, it's pretty straightforward. You're probably not going to need to write a leap year service anytime soon. I'm pretty sure Apex can probably do it for you anyway. So it's really just a very quick tour. Probably haven't seen massive advantages there, but I'm going to now give you a massive sales pitch on TDD. So what are the advantages of using it? Why would you want to use that? It'll probably look really arduous. But I think the thing is with test-driven development is that when you first look at it, when you first start, you're just like, well, why has he written all those tests? It's taken quite a lot of time to do that. He's had to split out the dependencies. I think the thing with test-driven development is there is an upfront investment, but you know the returns further down the line way outweigh the initial investment. So one of the things it does is it forces good architecture. So in that controller, how many of you would probably have just written that logic straight in the controller, for example? A really basic couple of lines? Probably would. I might have done it too, to be honest with you. If you're going to go with TDD and it was mandated on a project and someone's made a decision, we're going to use test-driven development, you are making sure that people cannot start writing code in triggers, they can't start writing code in controllers, you know, and they have to make sure that everything's decoupled. So you have to make sure that all of your code is in the right classes, you have to make sure that you've not got loads of static methods anywhere, and really it just forces people to not only structure their code properly, but because of the refactoring bit that we went over earlier, you're constantly revisiting that code. You're constantly looking at it. Can I make this better? What you're not doing is saying, I've got 5 days to do a 10-day piece of work. I'm going to rush through this as quick as I can and hope it works at the end. And if I have to write a quick hack, then I'll do that. How many people here have ever written a quick hack in a piece of code? You liars, yeah. How many of you put a quick hack in a piece of code and broken a bit of code as a result? Same people, yeah. We've all done it. And TDD is really going to kind of move you away from that a little bit because you just cannot do that. As soon as you go in, and it's one of those things as well that once you've been doing it for a while, at first you'll be forcing yourself, but once you've been doing it for a while, it will feel wrong. You'll lose sleep, you won't be able to go home at night because you know that that little SOCL query you've put in that controller should not be there. So also like debugging, I mean a lot of these things that, you know, they're all kind of, they'll only really become apparent when you start actually using TDD. So you're going to have to take me on my word a little bit and give it a try. Debugging, system.debug. How many of you put debug lines in your code everywhere because it may go wrong in 6 months' time and you want to know what's going on in there? Yeah, I've done that. I leave debug lines in there. If you're using test-driven development, you'll find you'll spend a lot less time debugging because you know what the code should be doing before you write it. You tackle that one problem, and that's it. It works. You might have to debug stuff, maybe if a little bit of code is not working, but because you're doing very small iterative steps of development rather than writing a massive system, it's a lot easier to know what's going on. Writing shorter and less complex code, again, I'm really sort of lecturing refactoring here rather than TDD, but because you're writing stuff, because you're writing your tests first, you're not thinking about stuff that's going to come further down the line. You're not thinking, oh, I might need to cache this data later, so I'm going to write a quick caching layer and stuff like that. And you'll find that as you go along, your code will be a lot tidier because you're only writing code that actually does what you need it to do. Fewer defects, we've touched on that already. Because of the way you go through this iterative process, you know, you will find less defects in your code because you're going to write a test that proves that each requirement works. And also off the back of that, you'll get instant feedback if anything goes wrong. So whether that's a new bug, or a missing requirement or anything, or you know, if someone introduces a new trigger, this is a fairly classic thing, someone introduces a new trigger and that starts breaking all of your unit tests. You know, again, if all of your requirements are met through test-driven development, you've got a test for each requirement. You'll know as soon as one of those things go wrong, not just when something blows up and it starts throwing exceptions, but actually if your code starts behaving differently. Code coverage, you must have at least 75% test coverage to deploy your code. Who's seen it? Who's seen that when they deployed code? Yeah, only me, apparently. We've all seen it. We've all had to get a graduate to quickly come in and write a load of unit tests, yeah? You're not going to see that anymore. So using test-driven development, typically, most of your classes are going to be 100% covered. That sounds like a really bold statement, but most of them will be. The simplest ones definitely will be. There is some stuff that you're not going to get to cover, but I would honestly, if you're getting less than, say, 95% across the board, and anything less than 90% on a single class, I'd be really surprised. So that just takes that worry away. Let's check my notes because I'm winging it a bit here. keeping you focused on a single task. So as I mentioned, we're not looking at the wider system. We're not sitting down for half an hour trying to design a massive piece of software that's going to do everything that we need it to. We simply take the first requirement and we write some code that does that thing, and then we move on to the next thing. Now, it might seem a bit backwards. There's a really good quote. I think it's a guy called Uncle Bob Martin. I don't know if any of you guys know this guy. I'm sure it's him that said this. He said, good developers, they're cursed with this problem, that they like to find generic solutions to specific problems. Yeah, we all do it. We're always thinking about what happens when that customer wants to do this, what happens when that customer wants to do that. And you may feel that that's something you should always do. You should always worry about what the customer may want 2 years down the line. But there's another school of thought that is, you know what, you're not going to need it. Yeah, you've probably heard of the Yagni rule. You aren't going to need it. It's a hard thing to do. In fact, when I demoed to Simon, who again is still not here, he did say I could use him as an example in front of everyone, and he's not turned up, so he's scared. That's exactly what he said. As soon as I started showing him the demo, he said, oh, what about if you want to do this? What about if you want to do that? And the whole point is, you don't care about that right now. When it becomes a requirement, you move on to it. Lastly, unit testing. It just makes you write good unit tests, and unit tests really are an art form on Apex. I remember when I came to Apex, I found getting to grips with Apex fairly easy coming from C#. But actually, how to write unit tests in Apex was really difficult, especially when you're looking at things like how to test exceptions, and you always come across something that you just cannot test. Keir, I saw you did a blog post a little while ago about field histories, right? You can't really unit test that. So again, there are things in Apex that are really difficult to test, but if you start with a test-driven development sort of process, not only will your unit tests get better because you're not just writing for coverage at the end, but you'll really perfect that art of how to unit test your code properly, which is really important. How are we doing for time? Not good. So barriers. So these are the things I'm going to convince you today are not real, and you should just move past them. Test-driven development, I know when I first started it, when I worked in .NET, and basically our manager came in and he said, by the way, we're now going to use test-driven development for this new program. And we were all absolutely livid. And we started out and we said, oh, it's really slow, and we don't like it. And that's really because there is a learning curve to it. And I think if you're an Apex expert, hands up if you're an Apex expert. Just Keir and Tom. Any other certified TAs in the room? No? Okay. We're all fairly good with Apex, I'd imagine, or some programming language, or we're confident with it at least. And I think what happens is people go, oh, I'm going to apply test-driven development now, and they think they're just going to walk into it because they're an Apex expert, it's going to be really easy. But actually, there is a really sort of sharp learning curve with test-driven development. It's not just writing unit tests, it's how do you write tests, how do you structure your code so that you can test it easily, and how do you remove dependencies, and so what I would say is, there is a learning curve. Don't go in expecting to be some kind of test-driven development master straight away, because you're not going to be. And it's really like when you first learn a programming language. How many people here have been learning Lightning over the last months? How long? Yeah, probably when you first did it. I know when I first started messing around with Lightning, I had an event that I just could not handle for some reason. I just could not find it. Spent hours and hours trying to figure it out. You're going to get that with test-driven development at first. Power through it. There's also a big investment. So, especially in the consulting world, who here works for a consultancy? Sort of 30–40% of us maybe. And, hands up if you work for a consultancy and you always have loads of time left over at the end of a project. No one. So, when you start a project, there's always going to be a conscious decision. If people aren't up to speed with test-driven development, there has to be a conscious decision to say, look, we're going to invest some weeks applying test-driven development, learning it as a team, and making sure that we all enforce it. Whoever's running that project needs to be on everyone, making sure they're following the right processes, making sure they're not cheating. There is an investment. And I think in the consultancy world especially, people just don't want to make it. But as I've already told you, you will get that time back tenfold. In terms of kind of learning test-driven development again, there are these advanced concepts that dependency injection and mocking. Now there are some other talks today, later on this afternoon. There's one on just unit testing in general. And I've deleted the note that tells me who the talkers are. But there's a talk, I think it's later on this morning, about just improving your unit testing and making sure it lasts. And there's another one this afternoon about Apex mocks, which is a mocking framework. If you're interested in test-driven development, if you're maybe interested in just trying it, it may be worth attending those talks because they do go into some of those slightly more advanced concepts. And these are the hardest bits. I think these are the bits where most people drop out of test-driven development because they just cannot wrap their heads around this concept. But it's one of those things, again, if you adopt it, take my word for it, if you adopt it throughout all of your projects, it's going to be fine, and you're going to get that time back. If you're halfway through a project and you suddenly find a scenario where you need this, it's much harder to plug in at the last minute. And also, like I say, when you first adopt TDD, you will go slower. That's a given. Happened to me, happens to everyone. After you've been using it for a few weeks, you will definitely find, and I've definitely found, you will start writing code quicker, which probably sounds strange. But I mean, I write all of my code to TDD all the time. I always write a unit test first. It's just second nature now. Another thing, so I was talking to one of my colleagues about this, and he said he doesn't like writing a unit test first because what happens if the requirements change later on? Then you have to rewrite all your tests, right? This is a really common thing. And yeah, that's true. I mean, if your requirements change, you are going to have to change your unit tests. But what I would say is that it's much better to, when your requirement changes, to go back and find a unit test that the requirement has now changed, because your unit tests are going to be focused around your requirements, right? And if your code is structured well and you've written your tests well, then when a single requirement changes, that should more or less equate to changing a test, if it's a simple requirement. It's much easier to go back and change that test, run it, make sure that test is now failing, go off and fix your code and push a button and know that everything else is now working, you haven't broken anything. That is a massive win, because what happens at the moment is, you'll go in and you'll just probably put in that quick hack that we talked about earlier, and you'll probably hope that it works, and you might throw it over to your QA team if you've got one. But really, when a requirement changes, there is always a big investment in time. The difference with TDD is that investment is up front, and once you've made that quick investment, it's win all the way. Traditionally, that requirement change, you're going to spend probably quite a lot of time regression testing, for example. You're going to be debugging code. Running out of time. In terms of, I think there's also a couple of things that are Salesforce specific. Like I said earlier, test-driven development, really prevalent in, I actually did a search on how many other languages support test-driven development, and it was like, unit testing really. It was hundreds and hundreds. I found a survey on GitHub that said in 2013, I think it was like 65% of projects in Java all had unit testing frameworks referenced. So in these other languages, it's really prevalent, but not in Apex. And I think a large part of that is down to the tooling. I know a company I was working for a little while ago. It would take 8 hours to run all their tests. To run all the test suite runs 8 hours every time. That's not good. You're never going to see that in the .NET world or in the Java world, because they just run straight away. We're in a multi-tenant system here. It takes time. I think the tooling's getting much better though. I don't know if any of you guys have seen, but more recently you can now run individual tests. You can run test suites. So if you're running on a particular piece of functionality and you've got 10 tests that cover that code, you can line them up, save them as a suite, and just rerun those ones every time. It's really good. Consulting lifestyle as well, I guess. That isn't really Salesforce specific, but probably applies to a lot of us. We have not got enough time, ever. Time and budgets, they're always against us. And it's a lot easier to suddenly go, you know what, that's just a really small change. I'm just going to hack that change in. I'm going to comment out the unit test. Still got 75% coverage. And as soon as you start doing that, you're going to fall out and fail, basically. Right, I need to whiz through these last couple of slides. Right, test-driven, how do you get started with it? Who here is now tempted to go away and look at test-driven development based on my speech? Oh, good, yes. Excellent, not wasted my entire week writing these slides then. So how do you start? So I mentioned earlier that there's always an investment at the beginning of a project to try and learn TDD. What I would suggest you do, if you're interested, first of all, feel free to get in touch with me or anyone else that knows TDD. There's lots of stuff out there on TDD specifically. What you need to do is you need to try and learn it specifically with Apex, probably, because there are some kind of caveats around it. Start off really small. If you've got like a little hobby project or something like that, or maybe just go off and write some little Mickey Mouse piece of code, like I did for this demo, and try and apply TDD to that and look at the kind of challenges you come up against, because you're not going to have time constraints, you're not going to have colleagues breaking your code and dipping out of dependency injection and stuff like that. You can be in control, you can go at your own pace. Coding katas, I don't know if anyone's ever seen these, but these are like little exercises that people do to learn coding. If you Google them, again, Uncle Bob Martin that I mentioned earlier, he's got some coding katas that are set up specifically for test-driven development. So there's a really good one that's around like a bowling scoring game, and that's because basically, as you get towards the end, it needs loads of refactoring. What I would say is, like I say, when you first start, it is difficult. Power through. Once you learn it, once you get to grips with it, you'll definitely reap those benefits. My last tip is just be pragmatic with it. Like I mentioned earlier, don't strive for 100% code coverage in Apex, because you'll spend 90% of your time trying to get that last 10%. Some things you don't need to cover, Or, you know, personally, what I like to do is I put my SOQL queries in your own classes, like a selector class, like if anyone's familiar with the Apex Enterprise Library. I really like that pattern. I don't tend to cover my selectors with tests because they tend to be covered by existing tests. I just don't see the point in writing loads of tests just to do a load of queries. And the other talks I was talking about later as well, Simon Lawrence is doing writing sustainable and maintainable Apex tests. David Frudd, true unit tests with Apex mocks. Any of those guys in here? No? Excellent. So yeah, check those guys out. Any questions?